Hey Rother fam, you just took some notes over nuclear fusion and the life cycle of stars, and I put some marshmallows in the crease of your journal, if you will, with 1 or 2 hands, and some of you got different amounts, and I'll explain why later. I dropped one. Okay, so take your marshmallows and then turn your journal to the front where we glued in a periodic table. And we're going to, my journal won't lay down flat, but let's see, will you get the idea? Okay, do you guys remember what determines the identity of an element? Okay, good. Protons. Now, how many protons does, say, iron have? Okay, good, 26. So we know that it's iron because it has 26 protons. Okay, now you have the makings of a star in your hand. Okay, we're gonna lay our star formation right here. Okay, where are stars born or made? Okay, good, in the nebula. And when a star is first born in that nebula, it is made of nothing but hydrogen atoms. So each of these hydrogen atoms is going to have how many protons? It's going to have 1. So we have a bunch of atoms with 1 proton. So what I'd like you to do is I'd like you to take 2 hydrogen atoms, represented by the marshmallow, and without squeezing too hard because it'll get gummy and we don't have sinks to wash everybody's hands. So if you will, just take this hydrogen, these 2 hydrogen atoms, and fuse them. This is called nuclear fusion. And what will happen is this is no longer hydrogen. This is now very good. Okay, now the star is getting older, and scientists can look at stars and tell their approximate age by what elements and how many elements are in that star. So a young star would maybe just have hydrogen and helium. So let's keep a hydrogen here. Let's get 3 hydrogens. Okay, we're going to fuse the 3 actually we would fuse the 2 together. Okay, and then if we fuse a 3rd one, so now this is helium, we said. If we fuse a 3rd one, we no longer have helium. What do we have? Very good. Now we have a bunch of hydrogens. We have helium. We have, hydrogen, helium, lithium. Let's put 4 together. So we fuse 2 hydrogens, 2 hydrogens. I just heard, I don't have that many. That means you're creating a younger star. Okay. Now, if these two heliums fuse, nuclear fusion, now we've got a star that has hydrogen, helium, lithium, and beryllium, and so forth. And they're going to keep fusing. And the question you wrote in your notes today was, what happens when a star runs out of atoms to fuse? And I believe
it doesn't fuse.
It stops fusing, and the star has ended its life cycle. Now, we're gonna talk tomorrow that a star's life cycle is going to go one of 2 directions. If it begins as a massive star, then it will take one life cycle. If it's a smaller mass star, it'll go another way. But you guys can fuse your hydrogens and heliums and lithiums, and you have created a star. And we are going to end the star's life by, if you choose to consume it, then you can go to your grown-ups today or your friend and say, I ate a star in science class today.
So I ate Bradley Cooper.
Thank you.